Hello class, I'm Jason Christensen. I was working with Mitch Harvey on this presentation. We are presenting on the template design pattern. To define the template design method or pattern, as indicated by the name, it basically creates a base class or a template class for subclasses to build off of, or for like objects to build off of and define further or explain differently. From one of our sources, here are a couple quotes that explains it. The template method defines the steps of an algorithm and allows subclasses to provide the implementation for one or more steps. The template method pattern defines the skeleton of an algorithm in a method, deferring some steps to subclasses. Template method lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. As an example, if we wanted to use the template class in our project, we would want our base class to be a generic list. Since we have different types of lists in our project, this base class list would define the generic properties or parameters of a list, including the items, different categories, the different ways to categorize, those type of things. And the subclasses for our project for these lists would be the different types of lists that we have: the recipe list, the grocery list, the pantry list. And these subclasses, or these different types of lists, would take the properties of the generic list and explain further how each of them would implement how to store the items or categorize them in their own different way. Another example is if we wanted to create a zoo app that included all the different types of animals in our zoo. We'd create the base class or the template class, which would hold generic functions and parameters for all animals, that would cover all animals, like how they walk or move, what they eat, what sounds they make, those different type of things. Then the subclasses would be the specific animals themselves. So if we had a lion, a bear, a dog, a cat, even a bird, a shark, then their subclasses would explain how they move, what they eat, what sounds they make.
In order to truly master the template method, you need to know the benefits and downsides of using it in order to decide when it is appropriate to use for your project, or when it is not appropriate to use for your project. The upsides to the template method are that it provides a framework. It gives you a base set of steps that you can copy for all your classes, and then the later steps are the only differences. This allows you to reuse a lot of your code with only small changes required for each instance. The template method allows subclasses to implement pieces of an algorithm defined in a superclass, and then these subclasses also decide how to implement later steps in the process. There are also a few downsides to using the template method, mainly that the template method is not always appropriate to use for your project depending on the circumstances. In order for the template method to be an effective design choice, all the classes need to have a similar nature. This means that the classes are relevant to each other, they function in a similar manner. This way, the majority of the code for each classes can be based off of a single template. The template method can also provide small amounts of confusion or cause developers to lose their place in the code. All of the classes are going to look nearly identical to each other, with only small changes between each class. Also, the developers need to have an understanding and mastery of using abstract methods, final methods, and how overriding methods works. And in some languages, like Java, using the template method can also cause subclasses to inadvertently change algorithms made in the main template, or the superclass. This can be prevented by declaring the superclass as final. Knowing if the template method will be an appropriate and effective design pattern for your project is not really that difficult. All the classes need to have a similar nature, with small differences between them. These differences are created by overriding the abstract methods defined in the template to tailor to the needs of the specific subclass. This strategy allows you to create many classes quickly and efficiently, with each of them being slightly unique and serving their own purpose. The template method is not appropriate when you need to make classes that are not similar or relevant to each other. If the classes work differently and serve different purposes, then the template method should not be your chosen design technique. A good example of an appropriate time to use the template method could be similar to the example that Jason gave earlier. Say we're making a children's application that helps children learn about animals as well as how to process information. The app would have a database of animals that give information such as how to spell the animal's name, what they look like, what sounds they make, what they eat, all kinds of information. First we would start out with a superclass called animal. Then we would fill this template full of abstract methods and member variables. These would be the information described earlier, such as animal diets and noises. Then we would make a subclass for every individual animal. Each would start out with the base template of abstract methods and variables and would alter them to tailor to the specifics of that particular animal. For example, we would have the lion subclass that inherits from the animal superclass. The lion would take the noise method and would output a lion's roar. The member variable name would become lion. Each variable and method would become specific for the animal that that subclass is based off of. All of the classes would be very similar to each other and function in a similar way. This allows the developer to quickly create many different classes by copying the template and using it on every class. That is why this app would be a great candidate for the template method. An example for when the template method would not be an effective design choice could be a banking application. There could be different classes for formulas used, such as calculating compound interest of your savings or calculating taxes, and a class that keeps track of withdrawals and deposits. We couldn't make a superclass that can effectively be used as a template for all these different classes because they all behave differently. It would take longer to develop each of these classes because the template used would be so ineffective. The template method, when used appropriately, can be very effective and efficient and save you a lot of time by allowing you to reuse your code. But using it in an inappropriate situation can lead to more harm than benefit, since it would take longer to flesh out all of the classes that are based on templates that don't really apply to them. So it's important to make sure that you are using the template method in an effective scenario. Thank you for watching our presentation. I hope that it was informative and educational. If you want to learn more about the template method as well as other design patterns, I would highly recommend Head First Design Patterns. It is a really good book. It's used in cs246 and has a lot of great information.